Advanced Financial Modeling, Topic 8, Financial Modeling with Python, Learning Objective number 2. We're going to write Python code that imports, exports data from and to Excel, manipulates data sets in Python using data frames, and then utilizes Python libraries or packages. So let's talk about this idea of packages or libraries. Packages or libraries are a collection of tools. I'll use the words packages and libraries interchangeably. And packages are most often, I think of them like Excel add-ins, like Excel's solver. If you want to use solver, you need to add it to workbook. Packages are available free from the web. However, the user must import the package into each Python notebook and program before running a program that uses the package. So we're going to import a package called math. We're going to open a new Python notebook. We're going to rename the notebook Time Series, Timeseries, and then we're going to run the command import math, which will import the math package or library. And then we're going to run a simple function out of math called square root to calculate the square root of 16. So let's go to Python. You want to open a new notebook and change this here to time series. I'm not going to change it since I already have a time series notebook created. So change that to time series now. And then we're going to import math. I'll do a shift enter. And then also what I'm showing you is you want to get help on any packages like math. You can just say help and then in brackets math. So we could do help math, and you'll get a description of the math package, and there would be a description on how to use the square root function. It would be down here. You can see it's SQRT. All right, so I'm going to then run another piece of code. I'm going to come down here to the bottom and let's say math.sqrt. So using the square root function in math, we'll do the square root of 16, shift enter, and there you have 4. So the idea again of these packages or libraries, they're a collection of tools, or you can think of them as functions that allow you to make calculations, do regressions, and all kinds of stuff we're going to talk about. So let's talk about some of the popular packages or libraries in Python. We just use the math one. There's also pandas and numpy. Pandas helps you organize data, attach labels to rows and columns. Pandas is one of the main data analysis packages. Numpy, N-U-M-P-Y, facilitates the use of multidimensional arrays. So using pandas and numpy really allow you to use matrices within Python. Matplotlib is for graphing and other data visualization. sklearn and stats models are used for data analytics. SciPy, S-C-I-P-Y, is used to solve math problems. And random provides random number generators. All right, so those are some of the popular ones. We're going to most often use pandas and numpy. And then later in this lecture, we're going to use sklearn, and matplotlib. So let's first get some data into our model. Often in the next lecture, topic 3, I'm actually going to show you how to get some data directly from the web. We're going to use Yahoo Finance and bring it into Python. In this topic, I'm going to upload data from my computer. I'm going to have an Excel file, turn it into a CSV file, separated value file, and then manipulate that file in Python. So let's grab this data set. You can actually go to the PowerPoint. If you don't have it open already, double click on this file right here, Microsoft Excel worksheet. And you can see what it's going to look like. It's going to be first column A is the year, month. Second column are Capital One financial prices. Third column, Walmart prices. And then Brew prices, SPY, IOO, EEM, and EFA. Brew is a small cap stock, BREW. All right, so I want to do is since I maybe created this data from Yahoo Finance. It's in a workbook. I want to save it though as a CSV. File, save as. I'm going to do a drop-down menu and save this as a CSV. And I'm going to give it a name of monthly prices, all lower cap, upper cap CSV. Monthly prices CSV, where CSV is uppercase. And let me just make sure where I save that. Let me save as. And I want to make sure that it is in my download folder. Let's put it in my download folder. Okay, so there we go. Now I'm going to go to Python, and we've already opened that new notebook and renamed it to time series. I'm going to go to this icon here on the left. Looks like a folder, like a hanging folder, paper folder. And what I'm going to do is take a look at or double click on it and see if there's any files uploaded there in that folder. And then there's not going to be any probably for you. And then I'm going to upload that file. So let's go back to here. I'm going to double click or single click there. And then I'm going to click on upload. And then I'm going to go to my download folder and click on monthly prices. Make sure your files are saved elsewhere. Okay. A little hint here, if you do this, come back later, you might find this your session of Python has expired and this monthly prices has gone away. So every time you go back to Python, maybe a few hours from now, you would have to go ahead and upload this file all over again. Okay, and you can just double click here and see if it exists. All right, so monthly prices is now in Python. Okay. If you look at the data, notice it is in descending order from 2019, I believe, down to 2014. And again, these are prices. And if let's take a look at the data here. This data here looks like an earlier version. I had dollar signs. Let's make sure that those were converted to just regular numbers, because that'll confuse Python. I'm going to double click on monthly prices. And then I'm going to look at it. And looks like I got rid of those dollar signs earlier, so that's good. Okay, here's what I want to do now. So what we're going to do eventually over the next 20 minutes or so is I'm going to calculate the beta of Capital One Financial. So what I'm going to, and the function I'm going to use is going to be a part of sklearn library. And I learned that you have to have the data in ascending order. They have to be returns, not prices. And I need to have a vector of Capital One returns and a vector of SPY returns, and then I can use this this object or function within this sklearn library. So that's where we're going to go over the next 20 minutes. So the first thing I want to do is read that file into Python. Right now it's just a file out there. It's not in that current notebook. So I want to read that file into the current notebook. I'm going to use a program or some code that does that. And so we are going to use the code from pandas. Panda, again, is a package or library. We're going to import pandas as PD. So we're going to import that and we're going to give it the name PD. And that's very common. You import, say, pandas as PD, and then you can anytime later refer to programs, or I'm sorry, objects or functions within pandas as just PD dot. So here's what we're going to do. We are going to import pandas into our notebook. I'm going to close this right here to get a full screen. If you need another line of code, just hover over the last line of code and hit plus code. But I'm going to import pandas as PD. Look, it's even given me a suggestion. A lot of suggestions are very good, and also you don't have to worry about misspelling. So I'm going to hit a tab, go to the end of that, and then I'm going to shift enter. So it's import pandas as PD. And then I'm going to run a program within pandas called read CSV. And what I'm going to do is I'm going to give a new matrix a name called df. It's going to be we call them data frames in the code here. So I'm going to give a new name. df is going to be equal to pd, that's pandas, dot read CSV. I'm going to hit a couple tabs there, and then all I need to do is come over here and replace data.csv with monthly prices. CSV is capitalized to match the file name. So that is some matrix, which is actually called a data frame inside Python. We're going to call it df is equal to pd pandas.read CSV. That's an object within pandas, and it's going to pick up monthly prices csv.csv and put it into something called df. I'm going to shift enter. Looks like I got an error there. Let's take a look what the error could be. Okay, it looks like file not found. This is a good opportunity to try to figure out what's going on. So it's not finding monthly prices csv.csv. So let me go back to my file folder here. Oh, and there's the error, monthly prices CSV. It is an Excel file. So let's pick up the CSV file from my downloads. That looks better. So I now have monthly prices CSV. I will close that, and now I can rerun df equals pd.read, and looks like it may have worked, but we can always tell by just typing df data frame to see what it looks like. Shift enter, and this looks great. Notice that I have in column A here, that first column, I have the months in descending order. Looks like the first row, it's picked up labels, and then I have prices down here. Let's run a couple other pandas programs. We can do a df.describe, open closed. What that's telling me is it's giving me all my variable names here, telling me 60 observations in each. It gives me the mean of each one, the standard deviation, the min, the max, so things are looking good. And then I'll also do df.info, open close, shift enter, and it tells me there are my variables. These are called the keys up here. Capital One, Walmart, Brew, SPY, IOO are the keys, or kind of the labels, the column labels. It tells me there's 6 observations. They're non-null, which is great. There's no empties, and they're floating 64. I'm showing this because the first time I ran this, I had the dollar signs from Excel still in there. And these did not come out as floating decimal places. They actually came out as objects. And later when I tried to do manipulations on the data, it was treating the prices as labels. So I had to go back, change the prices in Excel back to a number, not currency, and then redo all those steps. So it's just good to actually take a look at the data you import and see if it makes sense to you. All right, so what first thing I want to do is now, I know that I need to have my data in ascending order to run my programs. So what I want to do is I I Googled how to change, go from descending to ascending order of a data frame using pandas, and I wound up with this code. You just give the name of the data frame, ours is df, dot sort underscore values and then I also figured out the code, and I'll show you where I saw this. I'm going to do by then I need to give it my column. I want to sort by the first column. And in the data frame, the first column is called YYYY month month. So I'm going to do that. Comma, and in place equals true means to replace the data. And the true looks like it needs to be capitalized. So let's see how this runs. So we're going to sort df by the year month column, and I want to replace the data. In place equals true. Looks like it ran. Let's take another look at df. I'm going to add code df, and looks like we go from 2014 to, there you go. Looks good. Okay. So where I got that code, again, I Googled or ChatGPT it, probably Googling how to change or move from descending ascending order of a data frame within VBA. And then it sent me to this document here, which is a pandas document that talks about it. But I also was able to, it just suggested some code that looked like this, where it told me to sort by some column and say in place equals true. Okay, so far so good. All right, here's what we need to do now. I need to, from this data set, I want to peel off from df. I want to create this as an array called cof. And I want to create this spy as an array called spy, because I know to run my regression they need to be in separate arrays within Python. Then what I'm going to do is turn these into returns and turn these into returns. Then I'm pretty good to now run my regression. I have arrays of returns in ascending order. So here's what we're going to do. We're going to run this code. I want a new array called cof, and it's going to be within data frame, and it has the key of cof. So it's going to take cof column from data frame and give it a name of cof, and then take the column spy from data frame df and give it a name of spy, and then we'll take a look at them. So back to my code. I'm going to add a line of code. I'll just do two at the same time. cof equals df bracket, and I'll go ahead and put cof here. Here's an interesting thing that happened when it suggested code to me. This is actually very important. When this suggested code to me, I'm going to do the open bracket. It suggested that I use brew or cough or one of these, and I clicked on cof. Now notice there's a space before and after cof. I learned the hard way that this code actually won't work, because the actual labels within the data frame, also called the keys, has a space before and after, and I'll show you how I knew that. I figured it out. So I'm going to hit that copy. So I guess a couple things to think there. I'm always looking at the suggested code because there's some things to learn there. And I'm going to have spy equal spy, and let's go ahead and run both of those. I'll do a shift enter. And let's go ahead and just look at COF. Shift Enter. So COF goes from 59 to 0, 60 observations. SPY, Shift Enter, goes from 59 to 0, 60 prices. So I think we're in good shape. Also notice this is what's confusing to me initially when I was going from a VBA programmer to a Python programmer. We're not writing programs at this point. I mean, I guess you can call the collection of these commands within the notebook a program, but it's not a function like we've done before. We're just sequentially entering lines of code to do operations. So that's going to be a little bit harder to understand sometimes. It's just not writing a program, starting off with the word function and having to do a calculation. Okay, so we're in good shape now. We have our prices. Then I looked for some code. I need to change those prices into returns. I ran a Google search and I said, well, how do I, and within Python, and I may have put pandas in there, how do I turn prices into percent changes or returns? And it suggested that I use a pandas object called percent change, PCT change. And if you want the percent change from the last period, you just put a 1 in here. So let's go ahead and do that. We'll do two lines of code here. Let's call this new variable COF returns. Notice COF is capitalized and returns is not. COF returns is equal to the capital 1 financial prices. And look, there's a suggestion there. I'll do a tab, and put a 1 in here for one period change. I'm going to copy that code and also do it for SPY. Run both of those. Add a line of code if you don't have one. And let's take a look at capital 1. And we want to look at capital 1 returns now. We have a new array called capital 1 returns. And there we have 59 to 0, and those are returns. Unfortunately, the 59th is NaN, not a number. That's because when you have 60 prices, you're going to get 59 returns, and this goes from 0 to 59, so it's trying to force it to a vector that has 60 items. So we need to trim that in a minute. Let's also take a look at SPY. I'll just change this to SPY. Same issue. Okay, so now we have two new vectors called COF returns and SPY returns, but I've learned through some trial and error that I wanted to trim that data set from 60 elements to 59, and I did a Google, and this is what I got. I just can simply respecify the size of that array. So I'll do COF returns. COF returns is equal to COF returns, and I'm going to say 1 to 60, and it's only going to go from 1 to 59 because it goes one less that range evidently. And I'll do the same thing for SPY. I'll copy that, paste, and change that to SPY and SPY. Run those two lines of code. And let's take a look. And I'm going to do COF returns. Run that. And it's going from 0 to 58. Which is right. All right, one thing I'll warn you about, just from my experience, is if I made a mistake and I reran this code 2 times, it may trim it again. So you might find that, especially when trimming data, you may have to go back to an earlier step where you create the larger array again and then rerun the trimming, where this is just taking 1 through 60, which actually gets 59 observations. Okay. Now we're getting close to being able to calculate our stock beta. Let me just show, we now have 2 arrays. One's called COF returns, one's called SPY returns. One thing we could do is use matplotlib, which is a package for doing data visualization. So I can say something like, from matplotlib import pyplot. This is a common code, or a common library, and a common way of getting this. Shift Enter. And then I could do pyplot dot scatter, and it looks like it's giving me a suggestion there. I'm going to tab, Shift Enter, and there we go. We now have a XY scatter graph of SPY returns and Capital One returns. And then lastly, we are going to run a regression. I did a Google search, or maybe in ChatGPT, how do I run regression on stocks using Python in Colab? And I usually say in Colab because what you'll find is a lot of times when you find programs, there's a slightly different way of running or importing a package, whether it's in Colab or another environment. So what I found is this code here from my search. I'm going to import numpy as np, so this new package numpy, it's going to be called np, and then from sklearn linear model import regression. So I'm going to get also sklearn linear model regression. I'll specify the x, and the x is going to be my SPY returns. I'll specify my y as np array as a Capital One returns. Notice the np are utilizing numpy to deal with the arrays. However, the actual regression is being run from this sklearn. And then the program is saying model equals linear regression xy, and then we do print beta equals model coefficient. So what we can do is we can actually copy this code from this text box here. I'm going to copy. I'm going to paste. And there's my beta of 1.16. I went ahead and tested this in Excel by turning the prices into returns and using the slope function, and indeed this is the correct number, 1.16. Last thing we're going to do before we talk about the assignment for this section is I'm going to learn how to export data back from a data frame back to a spreadsheet. Well, at least a CSV that you can turn into a spreadsheet. So there's a code called to_SC or CSV, and it'll take some data frame, this one's called DF, to a CSV, and then you specify what the new name of the CSV is going to be. Here's the code here. I'll just go ahead and copy this. I'm going to add a line in here and run it. df.toCSV, that's a pandas code, and we'll just call it export example.csv. We can keep that name and just hit run. And then if you go to your file folder here, you then should see the export example, and looks pretty good. Okay, so this is doing a time series of data we downloaded or uploaded from Excel. Did some manipulation using some packages, numpy, pandas, matplotlib, sklearn, and might have been another one in there. And so let's talk about what you're going to do for your assignment. You are going to compute the data for brew in the time series notebook. Okay, so what's that mean? Go ahead and do this right now before this program, before the session ends, before your Python session ends. You're just going to rerun several lines of code. So you, again, remember that you've already uploaded the data into that DF. The DF has the prices. So you need to rerun some code that creates an array called brew, right? We already did this for COF. So create an array of prices called brew. Then I want you to run the code, and you're just going to do a lot of copying and pasting of one lines of code. And then you're going to convert the prices to returns, convert the brew prices to returns. Then you're going to trim the return data, the brew returns data, then rerun the regression, and all you need to do is copy the regression code I given you already, that last line of code we ran, and you just need to put brew returns in there instead of Capital One financial returns. And then when you run that, make sure you see what the beta is. I'll give you a hint, it's less than 1. And then go ahead and save that notebook. We're going to print that notebook as a PDF, and you're going to upload that to Canvas to show me that you've done all this. All right. The second thing I want you to do for this assignment, this should only take 5 or 10 minutes. Google or ChatGPT, ask it to generate a Black-Scholes call valuation for Python in Colab. You should get some pretty good code. Give you some hint. You're going to see some probably import code. It's going to import maybe numpy or pandas or something else. And then it's also going to be the actual programs where you actually see the parameters for Black-Scholes, and you see the calculations of D1, D2, and ND1 and ND2. And then I want you, once you get that program into Python, or you're going to copy from Google or ChatGPT, I want you to then call the program. I don't know what name you're going to have it. You're going to call the program and put in 100 as the stock price, 105 as a strike price, 3% interest rate, 1 year maturity, volatility 30%, dividend yield 2%. Then have Python use BS call. You can call the program BS call or just leave it to whatever name you found on the web. And I want to see the actual value of the call in Python. All right. You may need to install libraries, but when you Google or do ChatGPT, they're going to suggest libraries. So just make sure you copy that into Python. Then you're gonna do this in a new notebook. I should have said this. You want to do this in a new notebook called BS Call, and then print that notebook as a PDF, and that also gets uploaded for this Canvas section, or for in Canvas for this assignment. All right, so we're making some progress. This is Python for Finance.